Welcome to The Explainer. We're all about taking complex topics and breaking them down slide by slide so you can really see the big picture.
So think about this. You tap a button on your phone. Seems simple, right? But underneath, there's this incredible, invisible world of engineering that makes it all work. It's not magic, but it's close. Today, we're going to pull back the curtain on that world, using the core ideas from a truly landmark book, Martin Kleppmann's Designing Data-Intensive Applications. Okay, so let's jump right into the first pillar. You see, a really robust system, it isn't just about working perfectly when everything's going right. No, it's about surviving chaos. It's built to expect things to go wrong and to just keep going anyway. And that right there is the heart of reliability.
So the book has this great way of putting it. Reliability isn't perfection, it's resilience. I love that. Think about it this way. It's not a pristine glass window that shatters at the first sign of trouble. It's more like a run-flat tire on a car. It can take a hit, a puncture, and still get you where you need to go. That's the whole idea, to keep working correctly even when things are going wrong.
All right, so what's the biggest threat to this reliability? You know, when we think of a system crashing, our minds usually go to something really dramatic, right? Like servers catching fire or some backhoe cutting a critical network cable. But is that what really happens most of the time? The data tells a very different story, and honestly, you might be surprised. Okay, check this out. When researchers looked at huge internet services, they found something pretty mind-blowing. The number one cause of outages, it wasn't hardware failure. That was only about a quarter of the problem. Nope, the vast majority, a whopping 75%, were caused by humans. Configuration errors, mistakes made by the people running the systems. The biggest threat, it turns out, is us.
So if we're the problem, what do you do? I mean, you can't just get rid of human error. That's impossible. So the whole game becomes about building systems that expect us to mess up. You build in safety nets, things like an undo button for big changes, really clear monitoring so you can see when something's going wrong, and rolling out new stuff super carefully to just a few users at first. That way, a small mistake doesn't turn into a total catastrophe.
All right, on to our second pillar, scalability. This is a big one. It's all about how systems handle growth. You know, how do you go from 100 users to 1 million? How do you handle those massive, unpredictable crowds like on Black Friday or when a post goes viral, without the whole thing just grinding to a halt?
Before we can really talk about performance, we've got to get two key terms straight. First, there's response time. That's what you actually experience. It's the total time from when you click a button to when you see the result on your screen. But a huge piece of that is something called latency. Think of latency as the invisible waiting time. The time your request is just stuck in traffic, waiting in a line to be processed.
Now here's a super important idea. Averages can be incredibly misleading. They lie. If you just look at the average response time, you completely miss all the people having a terrible, frustratingly slow experience. So smart engineers, they don't look at averages. They look at high percentiles like the P99. What's that? It means they focus on the experience of the unluckiest 1% of users. And why does that 1% matter so much? Well, because a single bad experience can be enough to make someone abandon your app for good.
And this is exactly why that P99 is so critical. A single tap on your phone might seem simple, but behind the scenes, it can kick off dozens of different requests to back-end services. And here's the kicker. It only takes one of those little requests to be slow, and the whole house of cards tumbles. Your entire experience is now slow. It's this dangerous ripple effect called tail latency amplification.
So, when the traffic comes flooding in, how do engineers actually cope? Well, they've got two main moves. They can scale up, which is basically like buying a bigger, faster, more powerful computer. That's called vertical scaling. Or they can scale out, which means instead of one giant machine, you use a whole army of smaller, cheaper machines and spread the work across them. That's horizontal scaling. And honestly, most of the big systems you use today, they're doing a mix of both.
And that brings us to our third and final pillar. And this one's kind of the unsung hero. It's the one we often forget about, but it's absolutely crucial for any system that wants to stick around for the long haul. It's maintainability. This is all about building things in a way that other humans, and let's be real, our future selves, can actually understand, fix, and improve upon down the road.
At its heart, maintainability is about one thing: fighting complexity. It's about avoiding that tangled, confusing mess of spaghetti code that becomes impossible to work with. And this isn't just about fixing today's bugs. It's about making sure your software can actually grow and change with the business, so you're not forced to just throw it all away and start from scratch in a couple of years.
And the book points out that the real secret weapon against complexity is finding good abstractions. Now, what's an abstraction? It's just a way of hiding all the messy details behind a really simple interface. The car analogy is perfect for this. You don't need to be a mechanic to drive a car, right? You just need to know the steering wheel, the pedals, and the gear stick. That's a great abstraction. And finding those simple, elegant interfaces in software, well, that's one of the hardest and most important jobs in all of engineering.
Okay, so there you have it. Our 3 pillars: reliability, scalability, and maintainability. Sounds great, right? We want all 3. But here's the catch, and this is maybe the biggest takeaway from the entire book. You can't have it all. It's just not possible. You are always making a trade-off. And this is such a critical point. There is no magic scaling sauce. There's no one-size-fits-all blueprint for building a perfect system. The way you design a social media app to be super fast and handle viral traffic is completely different from how you design a banking app where rock-solid reliability is everything. Every single service you use is the end result of really hard decisions, of balancing these competing priorities.
So let's just step back and bring this all together. The next time you're just scrolling on your phone, I want you to remember what's happening just beneath the surface of that glass screen. There's this entire unseen world of architecture, and it's all built on these 3 fundamental pillars we just talked about.
Reliability, scalability, and maintainability. These aren't just, nerdy buzzwords for engineers. They are the invisible foundation of our entire digital lives. They are the reason your text messages actually get delivered, the reason your video streams without buffering, and the reason the apps on your phone keep getting better and better over time.
And the book wraps up with a really powerful thought. These massive systems, they don't just process abstract bits of data. They process data about people, about us. And so as engineers get better and better at building these incredibly reliable, scalable, and powerful applications, the author leaves us with one final and I think really crucial question. What is the ethical responsibility that comes with having all that power?